I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and sharing actual test questions. Now, here's a very beautiful question based on trigonometry 3D applications. The major problem which students face is skills to sketch the figure and to understand a very effective strategy. So, here is a question from one of our students. I like to explain you the concept of how do we read and then sketch the scenario as per the actual situation and then solve it using what we have learned. Correct. The question here is an asymmetric pyramid has a base in the shape of a kite, with longer sides of the base measuring 150 meters and the shorter sides measuring 120 meters. The angle between the longer sides measures 70 degrees. The angle of elevation to the top of the pyramid, as seen from the vertex between the longer and the shorter sides, is 75 degrees. Determine the height of the pyramid to the nearest meter. So that's the question for you. Normally in the class, when you work on pyramid questions, you have a rectangular pyramid or even a square-based pyramid. So it becomes kind of simpler for you to do the questions, but in exam, all of a sudden you get this kite, right? How do we control this kite? That's a big issue. So let's get ready for the real test questions and see how do we solve them. Perfect. That's what you learn on my website and in my channel. Well, directly, if you want to learn from me, send an email on the address given. So, first thing is we should accurately, when I say accurately, not really that matches, but kind of, right? Gives you a good picture of what they are asking for. So, we are looking for a symmetric pyramid, which is the base of a kite. Now, it's a 3D problem. So when you're making a base, it will be on the 2D, right? Or like on the tabletop. And then on the top, we have the pyramid right up on the roof, right? So let's see how do we sketch it. So now, let's say that the kite, which is in the diamond shape, we can draw like this, right? 70 degrees angle, right? So okay, more or less, right? And the other two sides are shorter in length, so this becomes the longer diagonal. So we have the other two sides which are shorter in length. Make sense? So this is fairly good diagram and practical, correct? So the lengths are 150. These two are equal, right? So these are 150 each. Units are meter, right? And the smaller lengths are 128. Let me write down here. Perfect. So that is given to us, and we are also given that the angle between the longer sides is 70 degrees. So this angle is given to us as 70 degrees. Now we need to find the height of the pyramid. So how do we get to that? We are also given that as seen from the vertex between longer and the shorter side, the angle of elevation is 75. So we could make a connection here joining these two. And let's say angle of elevation from this particular point is given. And the height we have to find. So let's think like this. Height, let me draw like this first. So that becomes the height. Joining one of the vertices, this will be a good vertex to take care of. So as you can see here, we have this particular height, and this angle of elevation is basically given to us as 75 degrees. Does that make sense to us? And that is the height which we need to find. Perfect. So if you make this kind of a diagram, then it may be slightly simpler. So I'm just connecting the other points with a lighter color, right? So that gives you the pyramid with kite as the base. Looks good, right? So read the question and try to see how the diagram matches with the given situation. Perfect. Since you have labeled it, it's absolutely clear that which side is what and what is the angle involved. Okay, how can we solve it? Okay, so basically we need to find the height. So we need to, let me just label this diagram first. So let's say this is AB, CD, and let's call this point as E. Let's call this O. Now, we can find AC using the two sides given to us, which are 150 meters long, right? So let's figure out what is AC. So AC can be found using cosine law, right? Since we know two sides and angle included, so we can find AC using cosine law. So AC should be equals to AB square plus BC square minus 2 times ABBC. Cos of angle between them, let's say 70 degrees for now. Okay, so AC basically is equal to 150 square plus 150 square. Let me write AC square, right? We'll do square root later. Okay, and 150 square minus 2 times 150 times 150 times cos of 70 degrees, correct? Now definitely if you have to find AC, you have to do square root of this. Not an issue. So now let's find out what is AC. We have 150 square plus 150 square minus 2 times 150 times 150 cos of 70, and then we square root it. So we get the value of AC as equal to 172.07. So I'm just writing approximately 172 meters. So we got the length AC. Now how does that help us to find the height? Well, this is a midpoint, right? And therefore we can say OC is half of AC, correct? Which is half of 172. So I'll divide this by 2 to find the value as 86. So we know that O to C is 86, right? So this side is 86. Now we know the angle of elevation being 75. Height is the opposite to 75. 86 is the base. So using SOHCAHTOA, you could use tan, right? Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So you can definitely use tan ratios, right? So tan of 75 degrees should be equal to height over OC. And that gives you the height itself, which is OC times tan of 75 degrees. Makes sense? So OC is 86, right? OC is 86. You can plug in the value and calculate, correct? So let's write down the answer here. So I'll just continue on this side. So the height H is equal to OC, which is 86 times tan of 75. Makes sense? So we already have 86 in the calculator times tan of 75 degrees. 321.09, so 321 height. So to the nearest meter, the height is 321 meters. You see that? So what we have done is that once you make a proper diagram, it becomes easier to visualize a strategy to solve the question. So we first utilized cosine law since we had a situation of SAS, right? Included angle. Finding the one of these diagonals, the midpoint being halfway, and that helped us to find the height of this asymmetric pyramid, right? So I hope all these steps are absolutely clear, and that should help you to solve any difficult question based on 3D applications, just as we did. Let me first again thank my subscribers for sharing such beautiful questions. And I hope that helps. In case you want to learn from me, feel free to send an email on the address given. Thanks for your time and all the best.